Come on. There we go. We should be live. In theory, we're live. Who can say? Who knows? But we'll go. So yeah, so no sign of the guest today. It looks like the power is out wherever she is. So I don't know what's going to happen because I think our docket is filled for the rest of the year. So we're stuck. So a special episode? I don't know. And for people who are going to be joining me on Sunday night for the virtual star party, just remember that we're kicking it back 1 hour so that we don't try to use telescopes in the sunlight like we did last week. So we're going to start at 9 p.m. Pacific time, which I know is midnight. I'm sorry. I'm Canadian sorry that it's going to be very late at night, but you can always watch it later if you don't want to make requests live, which is of course ridiculous. So because you want to be able to make requests, but we will. We'll get there. So I'm going to say hi to a bunch of people. Hello to Alex Disbland, Andy Cowley, Benjamin Valmont, Bob Moeller, Bort Klankar, Brexit Denier, David Fairweather, Eric Schneider, Eric One, Ian Farquharan, Johnny J, Larry King, Miss Scooper, Nancy Graziano, Paranor, Rich Wilson, Visto Tootie, and Zap Van Zap Van. Hey, everybody. Welcome. Did you guys have a solemn Memorial Day? No?
I don't think we do that yet.
No, you don't? We
No.
we do ours, we call it Remembrance Day. We do it in November on 11/11/11/11.
That's Veterans Day.
Yeah, you have the same thing?
Two.
Oh, you have two. Okay, well then
Yeah.
never mind. Yeah. We have BC Day. We just call it British Columbia Day. And we have Victoria Day. I think that was the one that we had. Victoria Long Weekend was the similar holiday to your guys' Memorial Day. Don't forget Horizon Brave. Okay, Horizon Brave. David Dunn, Wayne Francis, Jay Hapgood, Christopher Senti, Geek Savannah, Larry King, Scott Cox. And okay. All right. Well, let's get started then. Okay. I'm going to put you all back in your boxes. There's me. Joaquim. Yes. Alex is bland. Hello to Joaquim. All right. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, May 27th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Meerkat, solving the mystery of X galaxies. What happened with today's Crew Dragon launch? Clustering stars, stellar encounters in the Milky Way bulge. We may talk about toilets and some other topics. So stay tuned. This is going to be a little bit more of a free-form show today. But joining me this week on my screen, I've got Annie Wilson. Annie. We've got hello. We've got Moya McTeer. Moya.
Hi, good to be here.
And we've got Alan Versted. Alan.
Hi, nice to be back.
Yeah. All right, so before we get into this week's news stories, we're going to take a moment and give a huge thank you, of course, as always, to our good friends at the Weekly Space Hangout crew. This is the symbiotic relationship that we have with a great group of people who really are the executive producers of the Weekly Space Hangout. So if you want to be more active and participate in figuring out which guests will be on this show, if you want to talk to other space fans and obsess about the stories, especially during the dark times when we go into our summer break, which starts in about a month, you're going to want to hang out with these people. So go to wshcrew.space and they will hook you up. All right, let's get into this week's stories. So the big story, of course, Annie, Crew Dragon. What happened?
Not today.
Not today.
Dr. Pamela shared a meme earlier with me. It was the meme from Game of Thrones. What do we say to the god of death? Not today. And that's essentially the story. We say not today to death. There were all sorts of no-go weather conditions. I think what actually killed the launch was something about there's like 12 things that can cancel a launch. But it was something about like electricity, the electric field in the air, not to mention that there were storms in Florida, tropical, a literal named tropical storm off the coast, or
yeah, I mean,
it
when
was a
we were
mess.
going into the launch yesterday, and the weather just looked awful. And it really looked like there was no way they were going to launch this. But also, people who spend any time in Florida know that it can be a horrible thunderstorm, and then suddenly it's clear skies an hour later and it's perfect launch conditions. So they ran that right to the last minute. Did you watch the whole thing come together live as they were out on the pad and
kind of they started coverage way earlier today, and even though a rocket launched today, I still had other work to do.
Yeah.
So meetings,
Yeah.
and then popped over to Pamela's house where she was talking to the news, and I was running, our simulcast, and I was able to see the swing arm pull back.
Yeah.
And which was pretty like, oh no, this is really going to happen. They've pulled the swing arm back, because we were kind of hoping this would get scrubbed because we knew the weather conditions were so bad. And it was T-minus 1640 something when they finally did scrub it, because if this was not an instantaneous launch window, if they could have that additional 10 minutes, they might have been able to pull it off. But you need an instantaneous launch window when you're doing anything to the ISS, because fuel is heavy.
Yeah. And it was pretty funny to see, like, even President Trump flew in to be able to watch the launch. And my experience in trying to go and watch rockets take off is, don't book your return flight. Right? Like,
I don't think he has to book flights.
Yeah.
To be fair.
Yeah. Well, of course. Even so, if he wanted to watch a rocket take off, he better be prepared to just hang out off the coast of Florida, for, a couple of days, maybe weeks. My worst experience was to go see the space shuttle launch, and the second to last launch of the space shuttle, and I had like 10 days that I'd given myself to be able to fly back. And even that didn't make it. And back to the Cape. Nope, not today. Back to the Cape. Nope, not today. And then after a while, you're just like, no, this isn't going to happen. It's time to go home. You got to see the space shuttle, though. That was cool. So, yeah. And I saw other people had, like, even if people put their status, like, I'll be in Florida till the 29th. I'm like, oh, this is your first rodeo, isn't it? So for people who don't know what this is about, of course, what is Crew Dragon, and why is this such a historic event?
So this is the demo flight to Crew Dragon. Is literally SpaceX's commercial answer to getting humans in space again. And it answers Bridenstine's whole American astronauts launched from American soil on American rockets.
Yeah. And of course, the last time that this happened was back in 2011 with the space shuttle.
I think
Yeah,
so.
yeah.
It's been a hot minute. And today, if they had launched today, it would have been a meaningful date for SpaceX, because it would have been an anniversary of one of the very first tests that they did to even get everything going.
Right.
So SpaceX really wanted it to happen today. They pulled out all the stops, dog and pony show, everything, but
it didn't happen.
For the safety of the humans, not today.
Yeah. And in general, I mean, they can launch in various adverse weather conditions, but I think when you think about what happened with the various space shuttles, with the Challenger disaster, with the Columbia disaster, I mean, this rocket is really designed to solve a lot of the problems, to make the whole thing safer, and yet it still is not without its risks. And so NASA, being the safety culture that they are, they weren't going to take any chances whatsoever. If it had launched, and maybe by this time next week we'll be talking about how it did successfully launch, what should happen? What's expected to happen?
If it had launched, the astronauts would be in flight to the ISS for 19 hours, almost a whole day to get there. I think the Soyuz can do 6 hours, but the Soyuz has an advantage because the ISS is essentially aligned with their launch site and orbital mechanics, et cetera, et cetera, et cetera. So yeah, they would have been hanging out 19 hours, eating, drinking, sleeping, probably avoiding using the toilet. Yeah, just literally hanging out.
All right, so come on. You are an amateur toilet aficionado, space toilet aficionado. What do you think their toilet facilities are on Crew Dragon?
So everybody's been, both SpaceX and NASA have been very secretive and cannot or will not answer questions about the Crew Dragon toilet.
They so just funny.
Won't. People have been asking questions for well over a month, and you can't see anything that looks like a toilet inside the craft. You can't really see it in schematic drawings, but somebody said somewhere that it's above the astronauts' heads
to supporting our community.
If they were, in a 1G Earth gravity situation. And in pictures above the astronaut's head is a panel. The Soyuz toilet is stored essentially in a panel behind the wall, like a cabinet. And I suspect this is the same kind of situation where it's not something you sit on, it's something you straddle, and it's just kept tucked away behind a panel.
But I mean, 6 hours in a Soyuz, you can kind of hold it. Maybe, fill your diapers once. Yeah, maybe you do. No, probably not. You probably, you're going to have some, you'll be all jacked up on coffee. You're probably going to need to go a couple of times as you wait. But 17 hours or 19 hours, yeah, you're definitely going to have to use the facilities.
Your body in microgravity, it only takes 8 hours for your kidneys, for all the fluids to just go wherever they want to go because gravity is not keeping them where they should be.
Oh, okay.
So it takes about 8 hours for your kidneys to go, we have extra fluid we need to drain. And you have to go.
Let's
but
kick that overboard.
Diapers.
Yeah, that's funny.
As far as solid human waste goes, they have a breakfast. It's a tradition for American astronauts to have a breakfast of steak and eggs the day of a launch. And it is considered to be low residue, meaning there's not a whole lot of waste to come out.
Right.
So they do whatever they can to avoid using the facilities.
Yeah. So
Moya's just giggling.
Well, I saw a tweet earlier today, like an astronaut had posted a picture of steak and eggs, and I didn't understand what that was for, and now I get it. And that's part of their tradition. It's gone back many, many, many generations, and that is part of the low residue diet, so they don't have to use the facilities.
Right. All right. So it was scrubbed. So we won't get a chance to see this historic launch yet. Have you been tracking when the next window opens up?
Saturday or Sunday.
Saturday.
I had
both.
The launch window stuff open, and the weather still doesn't look great.
Yeah.
But we'll see. It can change. It can still change.
So we're looking at Saturday 3:22 Eastern, and then Sunday at pretty much exactly 3 p.m. Eastern. But in both cases, they've got about a 60% chance of good condition. So yeah. So no, this is it just goes on for weeks plan right now. Not to mention whatever. I was pretty amazed that they got to the point today where they did pull back the arm with the astronauts on board, that they did begin fueling up part of the rocket. Like, I was expecting just any tiny little thing to cause the launch to hold, but weather would do it.
Yeah, I thought it was for sure going to happen when I saw that.
People have been
I
arguing
saw it
on the
pulled back.
internet about what this is. And, you know, people have been saying like, well, it's not actually the last time astronauts have been off of or the first time astronauts have been off of US soil, because you know, if you like specifically are talking about the Kármán line getting across the, whatever's the 100 kilometers, that in fact the Spaceship 2 did it like a year ago and took some people on a suborbital flight. So but I don't think that counts.
I mean, it literally oh my goodness. There are so many ways that an astronaut or somebody that has reached space is defined.
Yeah.
And it's all based on what the definition is for. If it's just for somebody to getting to space, then yeah, like to get your astronaut wings or whatever. Yeah, I think it's actually lower than 100 kilometers.
80 kilometers? Yeah.
It might be. And that, again, that varies depending on institutions. Like the Air Force might have something or versus like the Navy's or NASA or whatever. And then not every person that we would have called an astronaut on the ISS is technically an astronaut.
Yeah.
Sometimes they're just spacefarers.
Yes. Yeah.
And things like that.
Yeah.
So
their cargo
definitions
that goes
are
to
funny.
Space. Yeah. Yeah. But I definitely feel, I mean, so how do you feel about this? Because it is a distinct change from, in the olden days, NASA built rocket ships and it put its astronauts on its rocket ships, and the astronauts went to perform missions in space. But in this case, they are paying really a commercial flight on board a very custom-built rocket precisely for NASA's needs, that NASA paid for in pretty much every single way. But it is, you know, it is a commercial provider with what's happening with SpaceX. So is this the future, do you think?
I don't know. I kind of grew up during the shuttle program and always took that for granted. Not going to lie, always took it for granted.
Yeah.
So I think this is better than nothing at all.
Better than
space
having Russians launch your astronauts?
It's better than not going to space at all.
Yes.
And the good thing about having a commercial partner do this is that SpaceX isn't at the whims of Congress and budget cuts and things of that nature. There's no twisting of hands, worrying that, you know, the budget's going to be cut, because this is a whole separate entity that can't be changed. Now, I'm sure that can all be changed with other policy things that I'm just not going to touch, but
yes,
that is the silver lining to it all.
Yeah, it would be really interesting to see if they can actually get off the ground, can fly to the International Space Station. Then it just continues to hold the SLS in more and more stark relief of this rocket that may never launch. And is just, the budget just continues to grow. And yet here you go, a couple of years, SpaceX built, I think it took 16 years for SpaceX to get this finally to a point that it can actually launch human beings into space, way beyond the timelines that I think anyone was ever anticipating. And yet they're going to do it, in theory, again, unless there's a horrible disaster next week. But it seems, you know, they've tested every part. The safety features on this is a far safer system than the Space Shuttle ever was. We've seen it, every piece of it tested quite successfully. So I like these odds. Would you fly in it?
If I had to go to space, and despite, you know, my penchant for space toilets, I don't want to go to space, but if I had to go to space, I would go to space in this.
Yeah. Arjun is asking, how much cheaper is this than using the Russians? I don't think it is cheaper. I think and I forget the total price for this. I mean, I think they pay, I don't even remember what they're paying the Russians per seat. But it's
millions of dollars.
Yeah, like 20
they're paying
million,
the Russians.
Yeah, 20 million, 30 million a seat or something like that. I forget the exact prices, but this is not about necessarily saving money. This is about, and even like the prices for crewed. I remember there was an estimate that came out like last year, and the the prices for even Crew Dragon, for commercial crew, were surprisingly high, shockingly high, and NASA is paying a lot of money. Like it's like normally you want to fly on a Falcon 9, yeah, $60 million and away you go. You want to fly on a Falcon Heavy, $90 million. Launch all the Teslas into space that you want to. But there you go. Luke Willem is saying it's 80 million a seat. Eric is saying it's 90 million a seat. Yeah. So it's definitely not cheap, but it gives the United States the ability to launch astronauts into space, which is key because they need to do this. So I think it makes sense. Here's hoping for a safe launch.
Yep, here's hoping.
Alan, thanks. And thanks for the toilet deep dive. Which is something that I will never say again. Was that train spotting? Alan, what have you got for us?
So I found out a while ago that there are such a thing as X-shaped radio galaxies, which was news to me, but apparently they're quite common. Somewhere between 3 and 10% of all active galactic nuclei present an X shape when you look at them in radio. I mean, we know what an AGN is. Well, I'm assuming most people listening have at least heard the term before. It's when you've got a large, when your supermassive black hole has got a large amount of material falling into it, it forms an accretion disk and it gets crowded and it gets hot and friction starts shining radiation, and then a lot of material ends up getting, ends up getting ejected into these two jets coming out on either side, and you get these distinct bar shape. But now some of them show an X shape, and there was always a bit of a mystery. Why? Why do you have these two, like the cross instead of just the lines? This is a new image that has come from that Fraser is showing us, that was created by the Meerkat radio telescope in South Africa, which is a precursor to the SKA. And it shows that the X shape is a bit more, it's not a cross. It's almost like two boomerangs, sort of. With my hands, I don't know if that's working to show.
Hold on. There you go. People, now you can show people the.
There you go. Right. Okay.
Yeah.
And that's brought an insight into which of the competing theories has explained what's going on there. Ideas originally that had been hypothesized had included that maybe it's two separate jets. So maybe you've got two supermassive black holes orbiting each other, each with its own accretion disk and its own jets. Other theories had been that perhaps the alignment has changed somehow. So what you've got is a jet, and then a new jet has just formed next to it. But it turns out that, according to this data at least, what's really happening is the material is shooting out, and then it is slowing down as it's colliding with the material within the galaxy itself and falling back in. And as it falls back in, it's very magnetically charged because it's all these high energy particles. It gets magnetically deflected into a new direction, which I don't know about you, but I had no idea that these things could get so complicated and so interesting. But there you have it.
Yeah, I mean, one of the things that's great. Another name for an active galactic nuclei is a quasar, and these are, of course, the actively feeding hearts, the supermassive black holes of the hearts of galaxies that are feeding on this material. And as they whip around, they fire out these jets, and as you say, this material goes out to a certain distance, but then it kind of rains back down onto the galaxy. And in fact, it's considered to be one of the additional ways that you can cause star formation to happen, to seed the galaxy, parts of the galaxy with heavier elements, and actually encourage some of the star formation. And so it might very well be that this is required. But Jump Out in Twitch is wondering about the similarity to a magnetar. It's interesting to see. I mean, the scale of a supermassive black hole or two of these, it is millions of times the mass of the sun, and yet it's the same sort of idea that you've got these really powerful forces twisting inside, generating enormous magnetic fields, funneling this material into these jets, and having this material sort of fire off into space. But this is...
I found it interesting because I mean, the last time I think a couple of months ago, I was on here and I was talking about a different set of galactic jets where rather than slowing down and falling back in, it just kept on going and was influencing star formation in another galaxy.
Yeah,
Huge distances away.
You can literally be blasting another galaxy with these jets and do the same job, where you're actually helping to create the star formation. Yeah, just a stunning picture. Have you gotten a chance to see the Meerkat Observatory?
I have not, no. I'd hoped to, and then we got this lockdown. So I
yeah. Well, so I mean, Meerkat is, like, as you said, right? Half of the observatories that are going to perform as the square kilometer array. Half of it is in South Africa and half of it is in Australia. And the Meerkat, I mean, they really did some incredible ideas and really pushed the envelope on what's possible with radio telescopes, and really defined a lot of really good ideas that they, I think, were able to show the steering committee that they should be placing these telescopes, using this technology and placing these telescopes in South Africa.
It's really astonishing what they've done. I mean, this is brand new stuff. We've never seen this kind of resolution before in an image like this. And then to think that this is just a little precursor. It's 64 dishes.
Yeah.
You know,
yeah.
The finished SKA is going to span across multiple countries, with that total collecting area of a square kilometer. I mean, that's insane. What are we going to get from that? It's incredible.
Well, the fact that I always like to use is that the square kilometer array, when it's finally complete, and we're still a decade away from it being complete, like 2030, I think, it would hear air traffic from Earth at a distance of 100 light years away. Like, it would hear, like, it would be able to detect the air traffic control systems on planet Earth. Just the leaked radiation from that far away, which is kind of incredible. So the aliens won't be able to hide, is what I'm saying, once the square kilometer array comes online. That's fantastic. All right, Moya, tell us about this interesting story that you dug up.
I dug up. No idea where I found it. For the viewers, the joke here is that I was lazy this week and decided to report on my own paper. So there's that. So when I'm now about to finish my PhD program, and when I started, I decided that I wanted to write my dissertation on this topic that some people would call the search for the galactic habitable zone. Or if you're familiar with habitable zones around stars being the place where planets can hold life, a galactic habitable zone would be a place in the galaxy where habitable planets are most likely to form. And this field has been alive since the 70s. People have tried to approach it from a lot of different angles, looking at chemical trends throughout the galaxy, looking at supernova rates, or looking at stellar number density to get a sense of radiation fields. I've decided to look at this from the perspective of galactic dynamics, or how the Milky Way is moving around. And this is something that we couldn't have done 10 years ago, even, because we only now have the type of beautiful, precise, and accurate data on the positions of stars and their motion in the Milky Way galaxy, thanks to missions like Gaia and Hipparcos. So this is something that we're doing for the first time, which is very exciting. But my work specifically was looking at how stars in the Milky Way bulge are moving. And the Milky Way bulge is this kind of spherical, dense part of the Milky Way right in the center. I don't know how many light years it is, but it's like the 2 kiloparsecs around Sag A star. And in the Milky Way bulge, stars are moving really fast. They're not moving on predictable circular orbits. And so they're interacting with each other, we think, a lot, or we thought that they were interacting with each other a lot. And I wanted to figure out exactly how often they're having these close stellar flybys. By close flybys, I mean stars coming within 1,000 astronomical units of each other. So I simulated the orbits of 1 million stars in the galactic bulge, and I counted how often they came in close contact with each other. And it turns out that 80% of stars in the bulge will come within 1,000 AU of another star every billion years. And that was the big takeaway of the paper. It was much more common than we thought it would be.
And so what's the implication of stars coming within 1,000 astronomical units of each other?
Yeah, this is where things got tricky. So we very strategically ended the paper there without talking about what the consequences to these planetary systems might be. But it really depends on what the masses of the two stars involved are, and like the angle that they approach each other and how fast they're moving by each other. But generally speaking, if you allow me to like just gloss over a lot of particular details.
This is just the Weekly Space Hangout. It's fine. Yeah. But this is not your dissertation. This is not your defense. Yeah.
Okay, cool. Hopefully my advisor isn't watching. But so in general, these types of close encounters can rip planets away from their host stars. That's the most extreme consequence. The next most extreme consequence is that the planet doesn't get ripped away immediately, but its orbit gets destabilized so that maybe 1 million years later, the planet gets flung away from its system, or it gets eaten by its star. It just spirals into its star. And if this encounter happens early enough, then it can completely disrupt the planet formation process altogether. But like the big consequence of this is that the architecture of planetary systems in the bulge could be very different from the types of planetary systems we see out here in the disk where the sun is.
But I know that, like, thanks to some of the recent research from the Gaia spacecraft, they were able to track back and see that, in fact, stars come relatively close to the sun every few tens of thousands of years. And by relatively close, I mean, say, 2 light years away, which is in the tens of thousands of astronomical units. So, but even that has been theorized to, say, disrupt the cometary clouds around these stars and send them inward to smash into potentially, into the inner solar system. And so, in fact, the cause of some of and you can imagine at various times they've come a lot closer than that. Maybe, would it be possible that the sun has had stars come that close to it within 1,000 AU? Would we know? Would we see that as the impact on the solar system?
I think we would see it. We would probably see it in the Oort Cloud, which doesn't, to my knowledge, doesn't look like it's had something actually come within it.
Right.
The Oort Cloud goes out to, like 2,000 AU, something like that, 2,000 to 5,000 AU.
Yeah, I think it goes out to 2 light years.
Okay, wow. Yeah. I mean, if something like came within 1,000 AU of the sun, it would probably completely disrupt the Oort Cloud. And we don't see evidence of that. Yeah,
it's like people always worry that a black hole is going to make its way through the inner solar system. And of course, if one came within many light years of us, it would already start to disrupt the orbits of the planets. Like, we would know because we wouldn't be here.
Right.
Just like the poor people who were formed on those planets in the galactic bulge. Is it similar then to the outcome of, like, if you were living in a globular cluster?
Yeah. So globular clusters are these really dense clusters of stars that can have anywhere from 1,000 to 10,000 stars in them. And they actually act very similar to the bulge, which is just a little bit denser. And so the work that I did, other people have done before looking at encounters in globular clusters and found similar encounter rates, but we don't have much observational evidence of this. We also don't have much observational evidence of planets in globular clusters. I think we've found maybe 10 planets in globular clusters. The whole point of my work is that I think rogue planets should be really common in the galactic bulge, which by extension should mean that they might be very common in globular clusters as well. But we just don't have enough observations to confirm or deny that.
And would they be common because they're more likely to form just on their own as a planet in situ in some teeny tiny protoplanetary some little protostellar disk that could only form a planet, or would they be more common because of the mayhem?
Because of the mayhem, because they could get ripped away from their stars or their orbits destabilize.
So what happens next? What's the next part of your research, do you figure?
Yeah, so I'm actually taking a step backwards in my research right now and looking at moving groups of stars. These are stars that aren't anywhere near each other physically. They aren't near each other in position space, but they're moving on similar orbits. So they're near each other in velocity space, or what we call action space. It's like their orbits are very similar. And I'm trying to actually identify these moving groups by looking at their motion and pairing that with their chemistry. So if I look at the chemical profiles or the metallicities of the stars that I assign to these different moving groups, then I can get a sense for how the moving group may have formed, because there are different mechanisms that can form these groups. But this is still tied to the theme of galactic habitability, because if I can understand how clusters of stars move with each other, then that just gives me a better understanding of how the Milky Way's motion changes over time.
Do you think, one of the things when you think about, say, habitability, or like the habitable zone of the solar system, it's always been this very, it's sort of like a very crude calculation where you're just like, these are the places where liquid water can exist. And therefore this planet is in the habitable zone. But really, when we look at it, we have to thank plate tectonics, a large moon, various compositions of the planet itself, chemical composition, the perhaps the necessity of a larger gas giant like Jupiter to either bombard or protect, how many flares the star itself gives off, et cetera, et cetera, et cetera. Right. And so it becomes a far more nuanced thing. And I know that with, say, galactic habitability, it's the same kind of thing. Like, no planets there, no life there, but life in the middle, because, the right amount of metal, but not too dense. But if you start to map out those stars moving around, could you actually maybe say, oh, actually, there's probably more habitability over in that region and less in this region, and let's use that as a way to direct our efforts?
Yeah, so you talk about defining the habitable zone around stars as crude, and I think when you start talking about galactic habitability, it's even cruder.
Yeah.
People have kind of defined the galactic habitable zone for the Milky Way as this annulus that's between 7 and 9 kiloparsecs away from the galactic center and outside of spiral arms, so that you're not in a super dense environment. And that's like, our sun is smack dab in the middle of that. Yeah. We're 8 kiloparsecs from the galactic
What
center.
A surprise. And here we are in the center of the universe again. Yeah,
exactly. We're so special and so lucky, but we actually are. I think introducing the idea of motion into it doesn't do much out here in the Milky Way disk, because things are moving on such circular orbits. For the most part, there's some perturbation from that, but we're mostly moving on circular orbits. And so the environment where you form your planetary system might be on the different side of the galaxy from where you are now, but it's because it's at the same radius, it's still roughly the same type of environment. So I don't think motion does much out here in the disk.
Right. When I'm assuming you've been all over the Gaia data. When does the next big data dump come? Do you know?
No one knows. I think originally it was so the last one came out in 2018.
Yeah.
And that was the second data release. The third data release was going to be a really big one. It was going to be an even bigger step between the second and third data release than there was between the first and second. And that was scheduled to come out in like 2023, 2024.
Okay.
Probably 2023. And because of coronavirus, it's being pushed back. The very final data release, the fourth data release for Gaia, was scheduled for late 2025. And now we just really don't know when things are going to happen.
Yeah. I mean, the fact that those upcoming data releases will give many more stars, potentially planets, and all kinds of other really interesting objects. Like I can't think of a mission that I'm more excited about
Me too.
than Gaia.
The thing I'm most excited about Gaia releasing in its final data release is the time series photometry data, time series astrometry data. So giving us information about how the stars are moving over time, but in like I don't know how to say it any better than time series. Instead of just saying the star has moved this much in the last 4 years, it'll tell us how much it has moved like every few weeks.
And so you could then run the universe or run the Milky Way backwards and forwards and watch how all the stars moved around each other in all of their different orbits, which is...
Or we could finally detect and confirm the first planet using astrometry, which would be very exciting.
Yes, please. Yeah. Using a technique where if I understand, you're like watching them face on because they're like yanking their planets or their stars in little circles.
Yeah, so the radial velocity method and the astrometry method are very similar because they both depend on watching how a star moves by being pulled by a planet's gravity. But it's just, you said it right, like a face-on view instead of an edge-on view of the system.
Yeah, so you're seeing the radial velocity, but on a completely different point of view, which is wonderful because it's the ones that it's amazing to think how few of the planetary systems we can actually see. They're like 1%. Like it's not a lot. But suddenly when we can see them face on, maybe we can see many more. So that's going to be the sleeper hit of Gaia, is going to be like, oh, and here's 100,000 planets.
Just like overnight.
Overnight. Yeah. Once James Webb is operational, here are a few targets for you to take a look at. So awesome. Well, congratulations. Assuming that life gets to return somehow back to normal, when do you get your PhD? When do I get to call you Dr. McTeer?
December is the goal. But I might choose to extend to May so that I don't give up a steady paycheck and health insurance.
Right. Well, got to let you know, 100% of Weekly Space Hangout co-hosts have gotten their doctorates, have successfully defended and gotten their doctorates. So we have a 100% success rate so far.
I will not screw that up for you, I promise.
With the two people who have done it beforehand. So with both Kimberly and Morgan came in as master's students and came out the other side getting their PhDs, which was great. Awesome. Okay, well, so we're going to probably run today's show a little bit shorter, but I just wanted to give you one interesting update, which is that we got an announcement this week that SpaceX is now planning to put their Sunshade on all future Starlink satellites. And of course, the big problem with Starlink is that they are very bright, not necessarily bright to the unaided eye, but they are bright to looking for the big telescopes, especially say the Vera Rubin Observatory, which is going to have multiple Starlink passes in almost every image that it takes. Starlinks are, say, magnitude 6, so they're just the limits of what you can see with your unaided eye, but that's really bright for a telescope. They were able to paint them black, maybe to get the magnitude down to like, I think 6.8. But it looks like they've got these visors, these sunshades that they put on them, and this looks like a pretty effective way to bring down the brightness. So far, there's 500 Starlinks, which are at their current brightness, but from this point forward, every launch will have more of these Starlinks with this visor. And this was done completely to minimize their impact on astronomy, which is nice to see them taking it this seriously. And hopefully this is the beginning, and there will be other techniques that will be figured out over time. But that first 500, we're stuck with them in their current level of brightness. Of course, they do have a limited lifetime. They'll probably only last about 5 years before they start to burn up in the atmosphere. So we've got about 5 years. Now, when you look at the timeline, there will be overlap between Vera Rubin and some of these bright Starlinks. So hopefully, especially in these times, right, where everyone's working from home, and those of us who have good internet have an advantage over the people who have to work from home in places with terrible internet. And this is what Starlink will do, is provide people who have terrible internet, who are in the more rural parts of the world, get access to as high-speed internet as anyone else. But, of course, these are SpaceX's promises. We're going to wait for the reality, but it's nice to see that they're committing to installing these darkening visors on every single one of their upcoming Starlinks. So I just wanted to give everybody an update on that.
I was
just
curious.
thought of the most horrible conspiracy theory.
Yeah?
That Starlink created coronavirus so that people would have to work from home and rely on their internet.
Lovely.
No.
That's monstrous. Yeah. No.
No.
Like I said, the most horrible
conspiracy theory. Well, if we see it start to go run rampant on the internet, we'll remember where it started. We're gonna have Twitter put little fact check thing beside everything you say from here on out.
I was curious to know. All the visual observers have been complaining about what Starlink has done to the sky. Have we heard anything from the radio astronomers?
They're the worst off, and they're, they have been getting sort of abused by satellites for decades. I mean, a lot of the times, we saw a presentation when we were at the American Astronomical Society from a radio astronomer talking about this, and that is a problem that has already happened. That there are specific weather satellites that as they go overhead and they beam down, they can actually burn out the sensors of the radio telescopes as they are blasting directly down at the sensors. So unfortunately, there's no easy way, because these things are literally broadcasting in the zone. That's the thing that you can't block. So unfortunately, they're going to have to do a workaround where as they head over radio quiet zones, they'll have to turn off when they do this. But that's been negotiated in the past. So I don't see it being like with just the physical reflective brightness of these satellites. You can't really turn that off as they head over top of the Vera Rubin Observatory, for example, and then let them, shine again. But with the radio telescopes, they can absolutely turn off all their transmitters when they're going over a place that's more sensitive and then turn them back on again. But if, you've got people in New Mexico who live right around the array, the Very Large Array, and they want to be able to access the internet, and the Very Large Array wants to have a radio quiet zone, then you're going to run into those problems. But we're going to definitely see, say, for example, when the Starlinks go into China, when they fly above China, they're going to have to turn themselves off, or there's going to be trouble. So I think we're going to see continuing negotiations with SpaceX and the needs of astronomers. All right, Alan, you're on my screen right now, so let us know what you're working on and where people can find out more.
Every time I'm on here, I make this elaborate promise that the new season of the Urban Astronomer podcast is coming out. I did it just 2 days ago. Season
awesome.
3 started. Yeah.
Yay, right on.
It was lovely. It's an interview with a professor of education that I've known for a while. And his interest is astronomy in science education. And we chatted a bit about the state of education in South Africa and how science outreach can work. Very interesting. Go find it at urban-astronomer.com. I enjoyed recording it, and maybe you'll like listening to it.
Fantastic. Moya, if people want to find out more, we'll put a link to your actual paper in the show notes.
Awesome. Thanks. You can find me on Twitter. My handle's GoAstroMo. And I have been working on my own podcast. It's called Exolore, and it's all about facts-based fictional world building, where I imagine what the life and culture might be like on alien planets.
That is so cool.
It's a lot of fun.
Yeah. Annie.
So you usually can find me overdoing CosmoQuest stuff. So that's twitch.tv/CosmoQuestX. There's a YouTube channel. There's a Twitter. There's all sorts of things. We go back to streaming next week. So I'll be streaming again starting next week.
You guys took a week off?
Yes, for Memorial Day. We just took the whole week off.
Yeah, that's smart. It's hard to sort of try to move around. I've done this a couple of times where I'm just like, you know what? I'm not going to do any work this week, and just curl up in your ball. And
especially with daily content, and we're trying to make sure we keep community coffee going. So that means twice a day streaming. It's a lot.
It really
it's a
is.
lot.
I don't understand. It's funny. Pamela always used to say, "I don't know how Fraser does it. I don't know when he sleeps. I don't know how he gets all this done." I don't do a fraction now of the stuff that you guys do. So turns out I'm
because
the
we're
slacker.
a team.
Yeah,
We're a team.
Yeah, I've got a team. So it turns out I'm the slacker, but good. Yeah, definitely go and check out all the stuff that's happening over on the CosmoQuest, both on the website and on the Twitch stream. You guys are doing incredible work, and I keep saying that. It's so funny. You could just see the moment Pamela started to be dealing with news every day, like her just because my job is to report on the news. I'm always up to speed on all the new advancements that I would be informing her. And now it's completely flipped around again. She's like, "Did you hear about this piece of research?" I'm like it just came out like 4 hours ago. So no. Yeah. So you guys are doing great work. And we definitely, if you haven't already, you should subscribe to CosmoQuest. We are going to be doing another virtual star party on Sunday night at 9 p.m. Pacific time. So just remember, it's 1 hour later. And that, as I mentioned at the beginning of the show, is so that we can have telescopes operate at night and not in the daytime, in the sun, in the sort of fading light of the day. So, but we had a great star party on Sunday night last week. We saw a lot of really great galaxies that I haven't ever tried to turn a telescope on. And it was surprising. We got the Whale. We got Comet Pan-STARRS. We got a bunch of the M51, M101, a lot of the classic galaxies. Sombrero Galaxy. It was the Owl Nebula. It was a really good time. So if you want to just come hang out for a couple of hours while we run a telescope live, you should join me on my channel on the Virtual Star Party. All right, I'm going to put everybody back up on the screen. There we all are. Thank you, everybody, for watching us today, both on YouTube and on Twitch. Thank you to all of the moderators, and especially Nancy Graziano for organizing everything. And thanks to my co-hosts, once again, for joining me here on the internets to share the science. And we'll see some of you next week. Thanks, everybody.
Bye-bye.